talk 2 hours about that question. And in fact, the inspiration is only the end result of a process that we call the percolation phase, where these neurons synchronize in order to take your breath. So that's why you don't breathe, you breathe. So a lot of neuromodulators, interestingly, affect this process and make it faster. But they don't affect the actual breath, because the actual breaths will slow down the next phase. So as I emphasized in my talk, exactly when these neurons are active plays a huge role. Before, during the breath, during the pause, and I think that's also when these different centers come in. They don't come randomly, but they can be combined during a gasp. The post-expiratory complex gets together, then you have no expiration. So I think there's a combination, but exactly when these things hit is very critical. So you wanted to say something, sorry. Yeah.
So actually, as you said, that now breathing is usually in the most of the yoga techniques, usually the expiration is more prolonged.
The expiration, yes.
Expiration is more prolonged than the inspiration in almost all the practices, whether you do the meditation or any breathing techniques.
Yeah.
Usually it has been taught that expiration is more prolonged.
That's fascinating. Exactly.
And as you said, the pause. Now there are a number of different techniques are there. A pause is given before the inspiration. Pause is given between the inspiration and the expiration, sometimes after expiration. Like a different technique. Now we don't know exactly, because the people have with their experience, they say, okay, this technique is better if a pause is given somewhere in between inspiration and expiration. Some other groups say the pause between the expiration and inspiration is the good one. And how much should be the pause? What we talk about here usually in terms of dosage, how much minutes the practice and how much the pause should be, how much that rate of the respiration should be, that exactly is not clear. Now based on the clinical evidences only we can recommend, okay, this much pause is better. Okay, now how much pause is better and what happens during that pause? What happens during that inspiration? What happens if you prolong the expiration? How much it has to be prolonged?
That is so cool. And these are, that's the question that need to be addressed very, very carefully. Much more than to say, oh, deep breathing. And to be honest, I mean, that comes out of the mechanistic side, because the mechanistic side tells you it really matters, this pre-inspiratory phase. It really matters, the phase directly afterwards. So you have to dissect the breathing cycle into the different components in order to understand which area of the brain with what kind of flavor it has for a higher brain function. And that's a conceptual change, you know. The conceptual change is not that it's all about oxygen. The conceptual change is that the neural signals that are generated during the different phases of breathing, they confer a different mental state. And now we have the techniques to do this, because we can activate very specific neurons during very specific phases to see, for example, whether they can learn more. I mean, whether they can control the hypertension. So we could think about an animal model where we mimic the deep breathing to see whether the hypertension goes down. You see?
Is it possible in the animals to mimic the same?
Sorry?
Is it possible in the animal models to mimic the same?
So people have done this. I've
Benedict was doing it.
Yeah, there are people that can train mice to do deep breathing. Now, I tell you, it's hell to publish this, because you have to control the oxygen, and then they say, you know, is it really the neural activity? Not, but hey, you know what? This is another thing where developing an animal model can take 1 year, but once you have it, you have a very interesting question. And I'm telling you, neuroscience is going about these questions. So, you know, we got bored about understanding how the lung gets open and out. We want to understand how it controls the brain. So I think your background is ideal for the future, because people are fascinated, you know, that what is the nature of the sigh? You know, why do we sigh? You know, is it like there's a sigh of relief, which is more emphasizing the expiration. There's a sigh of arousal, which is you know, more inspiration. So people, and we looked at mice, and they show that they are also sigh of relief, you know. So you can make an animal model, and these questions. This is material for Nature and Science, high impact journals. If you manage to convince the reviewers that it is objective, you know. But yeah.
Maybe you haven't seen a paper we wrote that's called, or several papers related to breath holding at high altitude.
Oh yeah.
And it's very interesting because, you know, the pressure right now, the inspired oxygen pressure here in Vijayapur is around 150 millimeters of mercury of oxygen. But at the arterial level, it's around 97, close to 100. So that means 50 millimeters of mercury of oxygen are not going to your system. Why? Why? You know, this is a question. And so our breath holding studies show that you can take a deep breath, and as you take a deep breath, the relationship between your dead space, because when you're breathing, you see, you have a tidal volume. You're breathing regularly. So every time you exhale, then you are pushing some air out of your alveoli outside, but part of it remains in your bronchi and your trachea. That goes back in again in this next breath. So when you take a deep breath, what you do is you reduce the ratio of the dead space to the volume, tidal volume at the alveolar level. So the dead space is reduced, and that way we are able at sea level to see with our studies with Nino has seen that we take it, you see our saturation was around 90%. You take a deep breath, and then after a certain time, the saturation goes to sea level value. So we go up to 98 from one breath, you see. But
if you hold the breath, it's crazy.
Just from holding your breath, you're going to sea level at high altitude. That's fascinating. So that may be of great use to you. And that's very interesting what you're doing, you know, because what you've been saying about the complexity of breathing, you see, the organism intends not to create turbulence in your breathing. It tends to maintain a tubular flow of air because that way it's soft air flowing into your lungs. You have enough time for humidity to be captured so that air enters your respiratory system. It has time to warm up, and so the marvelous nature and physiology has created this complex, and your work is so interesting because it's showing how the complexity, how it's not a matter of breathing in like that, because you will start hurting your system. You don't want cold air going into your alveoli, you know. It's not good. You will produce lesion in your alveoli. So the system has to regulate the speed in such a way, just like circulation with the hemodynamic pump, you know, circulation of fluids has to take, as you know, it's tubular, because the outer surface kind of slows down the circulation and the inner circles go faster. So there's a tubular type of flow. You don't want turbulence going into vessels like that. And so that's very interesting what you do.
By the way, I find it so funny now because in a way that brings me back to what I just said. You have to find what person loves. So if Gustavo would be in my lab, I would definitely not ask him to characterize the neural control of cortical activity. I would ask him to do blood flow measurements during meditation. And he will drive the project from this side, I will drive it from this side, and you bring us the reality of the yoga. And so that's kind of the key for science, is to bring the people with their own expertise, combine them in order to solve problems. Because I can bet you that I cannot turn Gustavo around, that he will not think about blood flow, you know, and oxygen and all that stuff, which is way too complicated for me. And I often forget that there's also a lung, but, so you cannot make me a Gustavo. So that's the trick, that's the whole trick. And all you have to do is let your people talk, and it takes you 10 minutes to know what is their true love, and that's what you follow, okay? So Gustavo, you're recruited.
I go.
Thank you.
Continuation with Dr. Satish Patil's query. Today morning you said that the cells have their inherent rhythms.
Yes.
Now in yogic breathing exercises, we are voluntarily altering those rhythms.
Yeah.
Now by practice, can we alter the inherent rhythms generated by the neurons?
Yeah.
Or once we stop yoga, why it comes back to its own initial inherent rhythm generating capacity, or by continuously doing those different yogic practices and voluntarily controlling the things, can we change the inherent
Absolutely.
discharges?
That's a very important question. No, it's okay, Kushan. I will not forget what you said, okay?
See, ultimately the basic of that yoga is that through the breathing, one can control the involuntary functions.
Exactly.
Like even the firing of the cells, as you said, the various rhythms.
Yeah.
So in terms of that, now through the breathing, what are the different rhythms which are present, as you said, in the morning, all those same, almost the questions of both of us are same.
Exactly.
Those different rhythms can be controlled. If controlled, how and what happens?
Yeah, but it's a different. So your asked question was different than what you answered, because you're asking the question: how does voluntary control the breathing? And you come from how does breathing control your apathetic? And both are playing a role. And when we look at our respiratory network, in fact, these neurons with autorhythmic activity, they are totally suppressed by inhibition. The breathing system doesn't want them to dictate the breathing. Because if you think about when I talk to you, it's a breathing behavior, which is entirely controlled by cortical activity. Because, when I want to say a long sentence, I take a bigger breath. When I want to say a short sentence, I take a shorter breath. And you never know, how good I control my inspiration, because it's a flow of talking, because it's cortical control. So I am suppressing my network from forming autorhythmic activity, because I'm voluntarily controlling it. And, but now the situation changes. So now I'm running. Okay, up the stairs, I go to La Paz, I run out of air. So what's happened now is I don't provide enough air during the talking. So I will talk like this. And so now my center becomes controller, because it says, I need more oxygen, I don't care how much you want to talk. So this inhibitory control that comes from above suddenly doesn't play a role anymore. And you see this also with little children, when they're totally agitated, they say, Mom, I got in this, whatever, So that's when they lost. So basically, you're all the time trying to control this, and your system is made to be suppressed. So now, however, it's an interactive process, because you not only control from going down, but you control also from going up. So that's happening, for example, when you're in a panic state. Like now you're panicking. You start to breathe faster, and the more you breathe faster, the more you get your cortical control out of these rhythms, and the more you drive yourself into a panic state. And only when you say, hey, calm down, it's okay, it's all okay, then you start breathing slowly, and then your cortical activity also goes down. So I think that we have to think it as a feedback loop that plays a role, where oxygen plays a little role, because if you don't have enough oxygen, then they will say, hey, you know what, you better breathe now, even though you want to say a long sentence. So I think, but what the yoga can do is they can control much more your breathing than they can override your oxygen hunger. You know, so basically they can calm themselves so much down, they don't get panic if there's a little oxygen missing, and so they can breathe totally slow without going into a panic, whereas I would go way faster into a panic, you know. It's the same thing like if I'm jogging, which I'm really bad at, it doesn't take much and then I go like this, whereas someone who's a good jogger, you know, they can run forever and they get stable breathing. And I can show you, I can tell you in fact one example. Every morning in Chicago I went swimming. And I tried to crawl, whatever, how you call it, you know, like this swimming. And I could manage 25 meters going down, back and forth, but I was then totally exhausted. And one day, my wife was in Norway, so I had a lot of time. So one day I was going swimming on a Sunday. In the morning I was swimming, and at one point I remember this one click moment where my breathing and the swimming were in sync. And as soon as it was in sync, I could swim for hours without getting out of breath. And basically, I still have this. You know, I can be out of shape as much as I want. I go into the water, I'm in sync with my breathing, and I can swim forever, you know, and it's really interesting. And I think people that are jogging, they find also their sync with the breathing, which I have not found. I'm still waiting for that Sunday when suddenly my breathing and the running becomes sync, because I don't have that. But I think breathing and movements have to be synced. And once they're synced, then you know you can be metabolically way more regulated because you don't start panicking. And I bet you also when you measure the heart rate during these movements, they're also in sync. And when you measure your sympathetic drive, it's also in sync. So I think what we are trying to achieve with our breathing and your cortical activity to bring all our systems in sync. And once we have that, then you know we're in kind of a meditative state. You know, so, and I think there are many examples. My brother is a guitarist, classical guitarist, and he has all these students, and he says he knows 2 minutes before the student makes a mistake because the breathing is suddenly not in sync anymore. So as soon as basically the breathing is out of sync, the person doesn't know that the breathing is out of sync, and then they make a mistake in the guitar, and so the same thing is for piano playing. You know, it's like you have to get into the zone where everything is in sync, and then you can focus on the music. And if you don't have that, it's like me jogging, which is really, you don't want to see that, you know, because it's not in sync. Yeah.
I have to add something.
Sorry.
It's all about
This is so exciting that we can't leave. We have to keep going. But you know, I wonder how yoga, I mean, if yogas do a lot of training, then it may be possible that their hemoglobin rises. Okay, I don't know about that, but let me tell you something. When we do a normal breath hold in La Paz of a normal person, like me, that has a hematocrit of 50%, you know, my breath holding time can go like for 40 seconds. Right? Take a deep breath, hold your breath, and we do this with the equipment that I have. And so you hold your breath and it goes for 40 seconds. You know how long a guy that has chronic mountain sickness, that has a lot of hemoglobin, it goes? It was a surprise for us because normally most people think these are sick people at high altitude, they are short of breath, you know. It's wrong, it's the other way. You have them, these guys have 70%, 75%, maybe 80% hematocrits. And you tell them, okay, take a deep breath, 30 seconds, 1 minute, minute and a half, 2 minutes, 3 minutes, 4 minutes, they hold their breath. They hold their breath really long. And we found a correlation between the hematocrit and the breath holding time. Okay? So maybe yogas, I don't know, check their blood. Because maybe they have, if they are, during their training, they become hypoxic and hypoxic and hypoxic, you should check their EPO. Maybe they are stimulating more hemoglobin production, and then they can hold their breath much longer because they have more hemoglobin. I don't know.
I knew it.
These guys are stimulating us too much.
It's too much fun. But you know, that's exactly why it's fun to run a lab, okay? It's because you have these guys that come with their own ideas, and it's a great journey. So all become scientists, it's fun. Okay?
Thank you, sir, for this interesting interaction. As we come to the end of this session, I thank Professor Gustavo and Professor Ramirez for such a lively and experiential interaction with all the PhD scholars. I am sure this interaction will help us in refining our research protocols and new insights we have got from their talks and lectures. And I wholeheartedly thank you, sir.
Yeah. And good luck. Okay, don't get frustrated. Projects next year.
I thank all the BLD University administrators for giving this opportunity to the PhD scholars for this interaction. And I thank all the PhD scholars for their active participation, and one and all those gathered here. High tea is arranged at the outside.
Thank you. Thanks so much. Good. Wow.